Okay, let's try a little bit more of a difficult problem. So we've got this example here. Thankfully, they give it to us in standard form and in factored form, which is nice. First thing I'm going to want to do is reduce this fraction. So I notice that I have an x minus 2 on top and bottom that goes away. So I end up with this. Now, from that reducing, I know I've got a whole. I know what needs to go in the whole because it's whatever makes that 0. So if I plug a 2 in, then the factor is 0. To find out what goes here, I'm going to plug 2 into my reduced version. So I have 2 plus 4 and 2 plus 2. Which you can simplify if you want to. That would be 6 over 4, or 3/2. Next, I have my vertical asymptotes. That's your denominator. Little reminder. So denominator, whatever makes the denominator 0. So I can see that my vertical asymptote is going to be x equals -2. Vertical asymptotes are always written as x equals equations. Wholes are always written as points. Now that I have my asymptotes and my wholes, I can do my domain from -infinity up to my asymptote -2, never going to touch it. From my asymptote -2 up to my whole, not going to touch my whole. And then from my whole up to infinity. Lastly, I have end behavior. So I have end behavior to the right as x goes to infinity, and end behavior to the left as x goes to -infinity. Now when I talk end behavior, you can either look at the standard form here, or you can look at the reduced form. Either one will give you the same answer. So let's look at our reduced form. It's a little easier. So we have x plus 4 over x plus 2. Now if I'm thinking as x goes to infinity, that's a really big number. So if I'm talking to infinity, this plus 4, that's not even going to matter because I'm at infinity. Adding 4 to infinity is not really going to affect much. Same thing with this plus 2. It's not going to affect much when we're at infinity. That's why we cross these out. I only want the biggest x, the biggest exponent, because that's the one that's affecting my equation the most. So now I'm left with x over x, and I'm actually going to use an arrow because those aren't equal. It's just one is leading to the other, which would then equal 1. So this tells me my end behavior as I go out to infinity is going to be 1. And in fact, as I go to -infinity, it's going to be the same thing. Because then I would have a -infinity over a -infinity, which is going to simplify to 1. So there's all our key features for one that's a little bit more complicated. In the next examples, we'll go through a couple more and then actually do the curve sketching for them.